Okay, just a note before we go on to equation number 2. You'll notice this specifically the AP textbook, the Walker text, and a different text depending on where you see it. Sometimes this, I'm just going to do this in red so I make this stand. Sometimes texts will omit the delta. But what they mean is that as time marches along, we can never do this without recognizing that time has to change. But because time always changes and we can't do anything about it, they'll often omit the deltas. And if they omit the deltas here, they're going to have they're going to address the delta d. So what they'll do here is they'll refer to d as x. So they're dealing with it in one direction. So they'll say x minus the initial position, right? And they might refer to it or have an arrow over it, or what they'll do is they'll bold it, right? They'll have the bolded x, and that's the same notation. It's meaning the same thing. That's a vector. So depending on the thing. So instead of a delta d, they'll have x minus x naught, and then they'll rewrite the equation where they say that x is equal to x naught, because they'll move it over to the other side, plus 1/2 v1 plus v2 t, and they'll write it like that. If you see it like that, you know what they're talking about. So like I said, the delta d's will be replaced with x minus x naught, and then they'll maybe rearrange it to have it like this. And the t, they'll often omit the delta. I'm not going to write the different ones. I'm going to use the original one because that's the sort of standard that we see in high school textbooks, for which the majority of us are studying. Okay, so but we'll move on to equation number 2. So if I take equation number 2, and I recognize that to get equation number 2, I'm going to have my acceleration again is delta v, change in velocity over change in time. I'm going to have v2 minus v1 all over delta t. So I can, if I want to rearrange this, and I'll say I want to find, if I start with an initial velocity v1, how soon will I get to v2, or how will v2 change over time, or how will my change, the velocity change? So I can rearrange this equation. So I can say that if I multiply both sides of this equation by delta t and times delta t, then I end up with a delta t is equal to v2 minus v1. If I rearrange this equation to solve for v2, so I can say that v2 then is going to be v1 plus a delta t. And again, maybe I will use the notation from the AP. So what the AP text would say that at any point in time, my velocity will be my initial velocity, they call v naught, plus a t. And again, they are the deltas. So this is the AP version. This is the but it's exactly the same equation. It's just drawn in a different way. But these are all. Okay, let me do this. I guess I am going to keep it. So the red is the AP text, AP notation. The blue is the sort of standard high school notation. And that's equation number 2. I'm going to save this video and record the next one.